Have you ever just stopped and listened to the world around you? I mean, really listened. You've got music, you've got people talking, the sound of traffic. But what is sound? Like, what is it really? Well, today we're going to dive in and break down the science behind every single thing we hear. All right, let's start with a little riddle. Think about it. You've got beautiful music, a happy laugh, and then a super annoying car horn. I mean, they couldn't seem more different, right? But believe it or not, deep down, they all share one single fundamental secret. And that secret is vibrations. That's it. That's the starting point for everything, every single sound you have ever heard in your entire life, from the quietest whisper to a massive explosion. It all begins with something moving back and forth really, really fast. So that's our first big idea. Before you can have any sound, you absolutely have to have a shake, a wiggle, a vibration. It's the spark that kicks the whole thing off. So what is a vibration? It's simply a type of energy. It's just a super fast back and forth movement. You know, like when a guitar string wiggles, or a drum skin shakes, or even when your own vocal cords buzz. And here's the most important takeaway. If you can stop something from vibrating, you stop the sound. It's a perfect cause and effect. No vibration, no sound. Simple as that.
Okay, this is so cool. This picture gives us a rare chance to actually see sound making things happen. Those amazing paint splatters, they are literally dancing on top of a speaker. The sound waves are making the speaker cone vibrate so powerfully that it's actually launching the paint right into the air. It's the perfect proof that sound isn't just something you hear, it's physical movement.
You know what? Let's make this real for a second. Go on, try this with me right now. Just place your fingers lightly on your throat. Got them there? Okay, now hum a low note. Feel that? That little buzzing? That tickle? That is the source of your own voice. It's your vocal cords vibrating, creating the very first step of sound. Pretty neat, right?
Okay, so we've got our vibration. But how in the world does that little buzz in your throat travel all the way over to someone else's ear across the room? Well, let's follow the sound on its incredible journey.
Now here's a super important rule about sound. It absolutely cannot travel alone. It needs a ride, something to travel through, and we call this a medium. Now this could be the air all around us, it could be the water in a lake, or it could even be something solid like a door or a piece of string.
And this is exactly why all those sci-fi movies with massive, loud explosions in space, well, they're not exactly accurate. A vacuum, like outer space, is pretty much empty. There are no air particles, no water, nothing for the vibrations to get passed along through. So if there's no medium, there's no sound. Period. Space is just completely silent.
I think the best way to picture how sound travels is to think about a long line of dominoes. When something vibrates, that's the first domino falling. It bumps into the air particles right next to it. Those particles then bump into their neighbors, which then bump into their neighbors, and on and on and on. It's this chain reaction, what we call a sound wave, that carries the vibration all the way across the room and right into your ear.
And get this, the type of medium it's traveling through makes a huge difference. In air, sound zips along at about 343 meters per second. That's way faster than a race car. But put it in water, and it's over 4 times faster. Why? Well, because the particles in water are packed way closer together, so they can pass that vibration along much more efficiently.
All right, so the vibration has been created, it's traveled through the air like a line of dominoes, and now it has finally reached its destination, the incredible, complex, and kind of weird-looking human ear.
Just think of your ear as a super sophisticated translator. First, the outer ear kind of acts like a funnel, catching the sound wave. That wave makes your eardrum vibrate. Then, these teeny tiny bones inside your ear make that vibration even stronger. And deep inside, a little spiral-shaped thing called the cochlea turns it all into an electrical signal. That signal then zips up to your brain, which, in an instant, tells you, hey, that was a laugh. It's an absolutely incredible biological machine.
So this brings up a question. Why doesn't every sound sound the same? How can we tell the difference between a high-pitched squeak and a deep, low rumble? Well, it's because the vibrations themselves have different characteristics, or, as I like to call them, their own personalities. First up, let's talk about volume. A loud sound, like if you bang on a drum really hard, is caused by a big, powerful, strong vibration. A soft sound, like if you just tap the drum lightly, comes from a small, weak vibration. The fancy scientific term for this strength is amplitude. So just remember, big vibration, high amplitude, loud sound.
And now for pitch, high sounds versus low sounds. A high-pitched sound, like a little bird chirping, is made by really, really fast vibrations. A low-pitched sound, like a big bass drum, comes from much slower vibrations. The term for this speed is frequency. So fast vibrations equal high frequency, and that means a high-pitched sound.
Whew, we've journeyed from a simple shake all the way through the air and deep into the brain. So let's just zoom out for a second and put all these pieces together to see the big picture.
So after all that, what is sound? Let's boil it down. It starts as a vibration. That vibration has to travel through a medium, like air. Every sound has a certain loudness, its amplitude, and a certain pitch, its frequency. And finally, our amazing ears catch these vibrations and translate them into signals that our brain can finally understand. That's the whole journey in a nutshell. And really, why does any of this matter? Because sound is one of the most fundamental ways we connect with each other and with everything around us. It's the tool for our music, for our conversations, for our laughter. It is, quite literally, a bridge between us and the world.
So here's a little challenge for you. The next time you step outside or put on some music, I want you to listen just a little bit differently. Don't just hear the noise. Think about the vibrations that created it, the amazing journey it took through the air, and the incredible process that's happening inside your ear right now. What sound, maybe one you've ignored before, will you truly listen to today?